The processing at the router is of immense importance in determining the overall latency of the whole path for source destination pair. In this module, we shall start with the most relevant understanding of the operations done at a router. The most well known technique, which is adopted at the routers for consulting the routing table for incoming IP datagram, the longest prefix match, is discussed, and then we look at ways to increase its efficiency. Anurag Kumar lays a lot of emphasis on assessing the overall performance of the router by assessing the size and the complexity of the routing table and the procedure adopted by that router to verify or compare the routing address in the incoming IP datagram. The operation at the router simply is a logical AND operation of the network mask and 32-bit IP address of the incoming datagram. If there is a match in the result, then forwarding is executed. If it is not, the packet is dropped or sent on to the default route. So the next hop is the corresponding entry which matches with the incoming address of the IP datagram. So the route lookup at real time is a search problem in real time. One of the most well-known strategies is the longest prefix match. Longest prefix match suggests that if there are multiple matches of the forwarding table within IP address, then which of them is the longest matching bit pattern with the incoming IP datagram. The scheme adopted in longest prefix matching as an enhancement or improvement is to go for binary tries. Binary try actually is a binary tree that organizes the routing table entries in the form of a binary tree such that the vertices of the binary tree at various levels, for example, at kth level, correspond to the kth bit. For a 32-bit IP address, if k is equal to 1, we are talking about the root node, and then the binary tree would be searched downwards. Since it's a binary tree, each vertex is going to have 2 children. So a k-bit prefix is expanded to k plus 1 bits prefix. That is, if we are at a place where 2 bits have been compared, then we are looking for the 3rd bit comparison and going deep into the tree. The route lookup now would be tracing the 32-bit IP address on this tree to find the right vertex. The entry in the forwarding table that matches the longest with the incoming IP datagram is the next hop. Let's look at the formation of a sample forwarding table and its respective binary try. Here we see that we have a routing table. This routing table is organized with respect to the binary try that we see here, that we have a root. Then on the left hand side, we have a 0, and on the right hand side, we have a 1. Similarly, on the left hand side, some of these options are shown. For example, 0 star, star implies it's a don't care, is A. So 0 star A is the entry that you see in the routing table as well. Let's look at another interesting scenario. Let's look at J first. J is 001 001 star, and we can trace J as 0 on the left side, then another 0 on the left side, then a 1 on the right side, a 0 on the left side, and finally a 1 on the right side. Now this traversal, as shown through this another example, is for G, and it is shown through the pointed red arrow. That first we move to the right for a 1, then for a 0, a 0, a 0, and all zeros. Now this traversal downwards in a binary tree gives us the most appropriate entry in the routing table.